Hi, so this video is going to be on Grignard Reagents, Organolithium, and Organocuprates. So, you may remember from Organic Chemistry 1, the SN2 reactions. So that's where you have your R1, your carbon compound with a leaving group attached, and also your nucleophile. And where the nucleophile goes in, attacks the back, kicks the electrons to the leaving group, and now you have your product and your leaving group off in solution. And so these typically, your nucleophile in organic chemistry 1, that's usually like chlorine or like an oxygen-based nucleophile, like alcohols, so maybe like ethanate or something. Usually it's gonna be like that. But let's say, what if what if you wanted to do something like that, but with a carbon nucleophile? Like Organic Chemistry 1, you learned, you already learned your carbanions, the carbon electrophiles, where, let's say, you got your ethanate, attacks there. Got your product. But what if you wanted a carbon nucleophile? So that's where Grignard reagents come in. And it's real simple. So you got whatever carbon you want there, magnesium, and then a halide, usually like bromide. It's not bromide or chlorine usually. Bromine or chlorine usually. Not fluorine. Fluorine doesn't work. But it's gonna look something like that. It's real simple to prepare them. It's just your alkyl bromide plus magnesium. So how it works is it's a radical reaction. One electron from the magnesium, one from the bromine bond. And then the third one, nope. Just one arrow. The third one goes to your carbon, which then you get R with the radical, Mg with the radical, and then Br. And then it's gonna pair up, and then you got your Grignard reagent. That simple. So it works how you'd expect. It's a nucleophile. It acts like a carbanion with a negative charge, well, with electrons to go to a bond. It's not actually that, it's just a really reactive bond, but it works very similarly, so let's see. You got your carbon compound and your Grignard reagent. Bond electrons are going to come, attack, kick off your leaving group, and then you got your compound of interest and a MgBr2. Just salt that's just going to be just floating around, not doing much. So then there's also organolithium, which is very similar. You make it very similarly, same way. Your your alkyl bromide plus lithium. It's going to be two unit, stoichiometrically 2 lithiums per your starting material of interest. Then it's going to react to form your organolithium compound and a lithium salt. So one thing to keep in mind with Grignard reagents and organolithium is you cannot use them in product solvents like alcohols or water. They will react violently and possibly explode because it's just that reactive. So let's say you have Li, organolithium, plus ethanol. It's just going to steal that. Grignard reagents and organolithium act as like strong bases, so it's just going to steal that proton off of there. You got your ethane plus LiO. That. So if you're doing this, it's got to be something that can't have protons taken from it. Like diethyl ether is common, and tetrahydrofuran. So 2 ethers, can't take any protons from those. And yeah. So a different reaction that these can do is with ketones. So you got R1, R2. So your Grignard or organolithium, whichever one, is going to come in, attack the carbonyl, pop the electrons up. Now you got your tetrahedral product, which through workup, which is usually just like quenching it with water, which destroys the rest of your Grignard reagents and converts that just to that just protonates that. You're gonna have your tertiary alcohol. So a different thing you can do with organocuprates is reacting with epoxides. So you got your epoxide, your Grignard reagent or organolithium. Your epoxide's gonna react there. Goes to the oxygen. You got your R. Your product, and then do a work up to get your alcohol. So, the other one is Organocuprates, which I mentioned here. It's a slightly different way to get them. You gotta go through Organolithium first. So, you got your RLI. And then a salt of copper 1, usually like copper bromide or something. That's gonna get you RCU. And then like IBR, but don't worry about that. But you're not done here yet. You have to react it with another stoichiometric of your R of your organolithium to get RCU R. Your organocuprate. If you only react it with one, it's gonna only gonna go to RCU, which isn't strong enough. So you need to get it to here so it can actually do stuff. So you may be thinking why to do organocuprates and what the difference between that and the Grignard reagents and organolithium is. And it's a lot of like a difference in strength. So organocuprates can't do the same ketone and epoxide reactions. It just doesn't react. But it can do something else that is useful. So organocuprates can undergo acyl substitution reactions. So let's say R prime and Cl. Got your acyl chloride and let's go with organolithium. So this is going to react, go up, and R, no, not. It's gonna get a tetrahedral intermediate, but acyl substitution, it's gonna come back down and kick off the chloride. So you get a ketone, and also you got a ketone, but they're strong. Organolithium and Grignard reagents are strong enough to react with ketones, so it's just going to react again. It's going to react twice, and then it's going to give you after workup, it's going to give you a tertiary alcohol. But organocuprates aren't strong enough to do that, so got our same acyl chloride, but this time we have our organocuprate. It's going to react just the same. And give you this. It's going to give you your ketone product, but it's not going to do it again because it's not strong enough to. So this is your product. So other than between organolithium, Grignard, and organocuprates, the difference between organocuprates is it's not strong enough. Between Grignard reagent and organolithium, it's about the same. Organolithium's stronger, so it'll react more vigorously. But otherwise, they do basically the same reactions. So I wouldn't worry too much about which one you use. I mostly used organolithium because it's a little faster to write out, but it shouldn't matter too much. It worked perfectly fine when I was in organic chemistry too. So anyway, that's it with these carbon nucleophiles. They're quite useful in a lot of reactions. Say if you wanted to, let's say you wanted say you wanted this molecule, but you only had this and, say, like, a Grignard reagent. Just reacts like that. And you got your molecule. It's that simple. So it's important making, it's a very useful tool for making carbon-carbon bonds, which is a lot of what you do in organic chemistry too. And it's how you make different molecules. So anyway, that's mostly it. So hope this helps, and good luck.